First of all, good morning to all of you. A very, very, very good morning to all of you. Let me give you a warm welcome on behalf of entire team Glecta. We are here to make the journey of GCSE exciting and learningful. And let's see how we are going to do this. Okay. And the first thing, Glecta is a brand which wants to go for education escape, and this particular space is such a space where there's a lot of improvement and development are going on in various fields, but nothing there everything at one place. So this is what we are trying to have everything at one place, so that the child need not to go number of places, right? So let's start with our methodology, what we do and how we are unique and how we are different from the rest of the such kind of developments. The first thing is our 4-step reinforcement approach. And this 4-step reinforcement approach, the first step, what we do on day one, it's a week approach. How our standard week goes. Let's discuss about it. The first step in the week is, for example, on Saturday, on day one, we give notes to the children, to the student, and the notes are very, very power packed notes and very, very easy to remember. Then what we do, we give him 2 days to read those notes. And after 2 days, there are going to be a main lecture class where our highly talented and qualified teacher are going to present the main lecture, which includes the latest development and technological advantage to make the lesson more interactive, right? And making that lesson more interactive in terms of videos, audios, GIFs, animations, and a lot of stuff, so that that would go into deeper to the brain of the student. There's a second part on the day 3, for example, on Monday. The next come to the third part of it, which is the revision and doubt. The same topic, the notes on day 1, main lecture on day 3, day 5, Wednesday, we are going to put a revision and doubt session of the same lecture. There's a kind of reinforcement of the same lecture, revision and doubt clearing session of the students. And when the 3 steps being done, the most important part is the practice of that particular thing. And practice is in 3 steps. First step is definitely the practice, which is a weekly ceremony. We do every week. Whatever we have learned in that week is a kind of practice on the day 7, which is a Friday. And definitely on Saturday or Sunday, you would get the results of the same, and you can see assess how much you have done in that unit. And after a month, we redo test of that unit with other units of that particular month, and finally the mock test of the entire syllabus. So it's a strategy, if you see, of weekly, then monthly, then finally the entire syllabus to cover the entire, this 4 reinforcement approach for Glecta, right? So this is our entire approach which we like to do, and there are a number of other things which I'm not covering here, like counseling sessions, our test papers, mock papers, and free number of other freebies attached to it. Now if I've already explained this is the first step is the note, second is the main delivery, main lecture, then the revision part, then the practice part. And now I would like to welcome our next teacher, who is going to produce the first demo class. And to welcome our next teacher, and let's start the demo, please.
Hello, students. How are you all? You can all turn on your mics and talk to me while I'm giving you the lecture. So how are you all? So today I'm starting with the first unit. In the first unit, there's a topic that I'm going to cover today, which is about your specialization in your animal cells. We're going to talk about how there are certain cells in our body that are specialized to perform certain functions. So let's get started. In this lecture, I'm going to cover 3 topics, first of which is how my cells are going to form a differentiated cell, which is specialized. The second objective is going to be to understand how these specialized cells are going to perform my particular functions. And the last objective is going to be how these structures are actually made specifically for the function that they ought to perform. Now in human body, all the cells actually come from one cell itself. That cell is your zygote. In the zygote, there's only one cell that divides itself and forms the baby body. And in that baby body, there's all the type of organs. For example, there are lungs, there are your gut system, which is your stomach, intestines, your heart is there, your liver is there, your kidneys, every part is there, which means your cells have to understand what they are out to perform, which means my cell have to grow up and they have to really understand what their functions are going to be. This is exactly what your differentiation and specialization of cell is all about. In your animal cells, these attainments of specialization are in the early stages of life, which means my baby that is born and come into this world has all the kind of specialized cells. While when we're talking about your plant system, this is something that develops over time. Your plant develops into a tree over time, right? So this is how the specialization will go on. Talking about your cell differentiation is not only about the cell itself. It is also about the kind of certain organelles and the subcellular structures that will be present in the cell itself, which means my cell has to have a structure that is only specified for the function. Also, the kind of organelles, for example, your mitochondria. Mitochondria is the powerhouse of the cell. So whatever specialized cell requires any amount of energy will have a lot of mitochondria. So these are the kind of subcellular structures that are ought to be present in my cell according to what is the function and the structure of the cell. Talking about, there are certain cells that are specialized, but they do not perform their functions collectively in a tissue system. Instead, what they're going to do, they're going to perform their functions individually. For example, your ovum, which is your female part of the cell, which is your female gamete, and your sperm, which is your male gamete. Both of these do not associate themselves with any kind of tissue system. Instead, what they do is that they perform their functions individually. In your syllabus, you have to talk about the specialization of 3 cells. So let's start with the first one, which is your nerve cell. So nerve cell is going to carry my information from one part of the body to the other part of the body. While I take this specialized cell, I want you to imagine your body. For example, there is certain amount of heat right in front of you. For example, you're standing in front of your stove and you're trying to touch something. So there's going to be heat and your hand is going to touch that heat, which means your hand is going to burn. I want you to imagine such a scenario so that I can explain you better. So this signal for the heat is going to be transferred from your hand to your brain, and then it's going to come back from your brain to your hand so that you can pull your hand back, which is your reflex. The second thing is that this entire communication of the impulses has to be very, very rapid, which means you do not need to give your skin time to get burned. You just touch it and you retrieve your hand because you felt that it was hot. This is how your impulses are going to be transferred. This is a nerve cell. We're going to talk about the structure too, but this is how your signals are transferred in different kind of cells. Talking about the adaptation. Now I said that my cell has to adapt and has to specialize itself because my nerve cell is also coming from a single cell, which was my zygote, which means my cell has to have certain different kind of structures that will help my cell to perform all these functions. So these are the adaptations, and this is my diagram. So whenever I say certain amount of structure, you have to look at the diagram and look at the structure. So first adaptation is dendrites. These are your dendrites. Dendrites will make connection from one neuron to the other. For example, this is my fingers are where the skin parts are, and this is my dendrite. So my dendrites are going to touch this part, and whatever this signal is wanting to give my body, my skin is trying to send certain signals to my body. So these will be transferred from the skin side to my dendrites. My dendrites are to collect the information. Other than that, there is axon part, which is the longest part here. My axon will transfer the impulse from the dendrite part to the body of my nerve so that it can reach the other end of my nerve cell. So this will carry my impulse from one place to the other, from my dendrite side of the nerve cell to the nerve ending side of my nerve cell. Then my axon has to be long. In a blue whale, this is approximately up to 25 meters long. So imagine how long my axon can be. Other than that, the longest axon in human body is starting from the base of your spine, from where your spine ends to the toe. Your biggest toe will have the last nerve ending of that longest neuron. Then there are other parts of my neuron, which is nerve ending. Nerve endings are going to be the part that are going to draw my attach my neuron or the axon part to the next dendrite. So this is going to be the nerve ending of the first axon, first nerve cell, and this is going to be the dendrite of the next. So this is like a series that goes from your head to every single part of your body. Then there's another thing which is known as synapses. Look at this. This is receiving signals from the dendrite part. This is my cell body getting from the axon, then reaching my other cells, dendrite, then again going. This part where my nerve ending of the first neuron and the dendrites of the second neuron are meeting, this is known as synapses. This synapses, let me write it. This synapse is it's like the junction between two nerve cells, which are also known as neurons, like I said. So these are going to join and the cell impulses are going to jump. So what happens is these are not joined like that. Nerve endings and dendrites are never in connection like that. Instead, they're in connection like this. So when the nerve impulse is going to reach my nerve ending, it is going to jump to the dendrite and then go further. Talking about the second specialized cell, it is going to be your muscle cell. Muscle cell are for contraction and relaxation. This is how muscle cell will contract and relax. For this, I want you to imagine that you're showing your biceps to somebody. So you pull your hand up, your biceps are going to contract. If you release your hand, they're going to relax. Similarly, with your fist, this is contraction, this is relaxation of your fist muscles. The striated muscles, now my muscle cells are of different types. There can be different type of muscle cells according to where they are present. For example, your biceps are going to have your smooth muscle cells. Other parts of your body can have striated, or heart muscle cells specifically have cardiac muscles. So they're going to work together, and this entire work frame of different kind of muscle cells is going to form your muscle, which is your layman's language about how your muscles work. Then the contraction and relaxation is always going to be in pair. There's going to be two cells that are going to help in contraction. The other one is going to relax. Other than that, this is how your muscle cells look like. Now, if you think of it, my muscles need to contract and relax on daily basis. I mean, if you imagine the amount of contraction and relaxation that you do, for example, I'm talking to you, I'm continuously moving my hands. There's a lot of contraction and relaxation happening in my body, which means my body needs energy every time that my muscle moves, which means there's going to be a lot of mitochondria present in your muscle cells for that contraction and relaxation. You're continuously walking, you're continuously talking. Walking will require contraction and relaxation of your leg muscles, and talking will require contraction and relaxation of your face muscles. So similarly, the contraction and relaxation doesn't even stop when you're sleeping. If you're moving while you're sleeping, that movement will also require a small amount of contraction and relaxation. Talking about the three adaptations that specifically are seen in my muscle cells, the first one is that they're going to have special proteins that will slide together to contract and form my fibers. The second is a lot of mitochondria will be present, which is like obvious because my muscles has to move, and there's going to be contraction and relaxation that is continuous. So muscles will have to have mitochondria for the energy requirement of the cell. The other is that there is a presence of glycogen. Glycogen will convert this, glycogen will be converted into the energy by mitochondria. So mitochondria doesn't really work without your glycogen. Glycogen is like the energy source. My mitochondria will take glycogen molecules and it will turn them into proteins and other types of energy molecules such as ATPs. This is how your smooth muscle cells look like in your body. And these are different kind of muscles. If you look at the muscles, they move like this. This is one muscle, this is other. My pen is the third muscle. So what is going to happen? These are going to move forward. The other one is going to come out. Then they're going to move back, and the third one is going to move inside. So this is how contraction and relaxation continuously happens. This movement of my muscles will never stop. Then the third specialized cells that you have to talk about is your sperm cell. I hope you all know what sperm cell is. It is the gamete of your male body. This is going to carry my genetic information from my male parent to the next generation, which is going to be the baby. So my cells are going to be specialized in a way that they will have to carry the genetic information. Genetic information is carried out in the form of your DNA from one cell to the other, which means your parent cell, or your male cell, which is your father, into the baby. Then they have to be able to move. They would have to have a capability of moving either in water for certain kinds of animals. For example, frogs lay their eggs and sperm into the water. So their sperm has to have a capability to move into that water. Otherwise, they would have to have a capability of moving into an reproductive tract of the female so that they can reach the egg cell. And the last thing that they have to do is that they have to break into the egg, which is your female gamete. The first diagram here, the first GIF, is showing how my sperm has a capability of moving. The second shows how my sperm is capable of getting inside the egg cell, which means how it breaks into my egg cell. The next is the adaptations of your sperm. The first thing is that it has to have a long tail. Long tail will swing like this and would let my sperm move into the medium, whether it be water, for example, in frogs, or it will have to move into the reproductive tract of the female, for example, in humans. So it will have to have a long whip-like tail. The other adaptation is that the middle section will have a lot of mitochondria. Now, this is again a very, very common thing, that moving will require energy. Energy comes from mitochondria. So energy will be converted in the mitochondria, and my sperm will have the energy to move into the medium. The third is acrosome. Acrosome is not a very common thing, which will be okay that you guys do not understand what acrosome is. For a simpler version of your body, acrosome is the one. For example, this is my egg cell and this is my sperm. My sperm has to get into the egg cell. It has to break the walls of my egg cell and then get into it. So this acrosome is the enzyme that will break the wall of my female egg and let the sperm get into the egg and then form a zygote. The last is that it is going to have a large nucleus. Why a large nucleus? Because it has to have DNA. If DNA is present, genetic material will be present, then the genetic material can be transferred from the parent body to the baby's body. Look at the diagram. Head will have acrosome. Why will my head have the acrosome? Because acrosome is, if it is present here, it will come in direct contact with the egg cell. So first thing that comes in contact between your egg cell and the sperm cell is actually the acrosome. The second is they're going to have cell membrane around the sperm. Then there is nucleus having my DNA, the genetic material. This is the middle piece, which is going to have your mitochondria for the energy. And this is your tail, which is also known as flagellum. Flagellum is a word for a singular thing. If there are a lot of tails present in any kind of organism, it is known as flagella. Flagellum is a singular word. So this is my tail that is going to whip around into the medium so that my sperm can move. This is the summary of what I've taught you. Our lectures, as the sir told you, they're going to be in 3 parts. So the first is going to be your lecture. This lecture is going to let you have all the information. These kind of mind maps will be made so that you can understand what you were taught in the last lecture. So let's revise this first. The first cell that we talked about was your nerve cell. This is how my nerve cell looked. There were dendrites, there were axons, and these were nerve endings. What is the function of my nerve cell? It is going to provide rapid communication system between different parts of the body. For example, skin that is in your hand to your brain so that you can pull your hand back. Another example on a very daily life basis would be if somebody tries to slap you, you flinch back. Every time that you flinch back, it is actually your brain telling you that you need to protect yourself. So move back because the person standing right in front of you is trying to hit you. The other cells were muscle cells. These are 3 types of muscle cells. Then what is the function? They have to contract and relax together so that my body can move. Specifically, my bone and the skeleton system can move. The third cell that we talked about was your sperm cell. Sperm cell has a structure with a tail. Here there's going to be mitochondria. This is your nucleus, and head will have your acrosome. What is the function of my sperm cell? That it has to contain certain amount of genetic information so that it can be transferred from the parent body, the male parent body, to the baby's body or into the zygote. Now you can, each one of you slowly can turn your mic on and tell me if you've understood it so that we can move to the next part where I'm going to ask you questions. Okay, so I'm going to move on to the questions. Okay, so the first question that arises from a topic like this is that we're going to have 3 cells. I want to ask which one of these cells is a nerve cell. Oh, it says 4. Let's make it 3. So there are 3 types of cells that we see. Out of which one of these? I didn't understand the nerve cell. Okay. Okay, let's revise first nerve cell so that you can understand. Okay, this is the first slide for your nerve cell. Now, while I tell you again about the nerve cell, I want you to imagine that somebody is trying to hit you, because the first example that I took was about heat. Let's take it as a very, very basic example that can happen anytime in your life. So imagine somebody trying to hit you. The first thing that comes to your head is that you have to move back. So that is because you're flinching away from that stimulation that somebody is trying to hit you. So what my nerve cells do is actually tell your brain that somebody is trying to hit you, and then your brain tell you that you have to move back. This is the kind of special electrical impulses that will move in your body. Anything can happen. For example, if somebody touches you suddenly, you get scared, you get startled, and you move back and see the person. That is the kind of reaction that are going to come because of the presence of these cells, which are your nerve cells. The second is the rapid communication. Now, imagine if you have a hot pot right in front of you and you're trying to touch it. As soon as you touch that hot pot, it is going to burn your skin. Your brain doesn't want you to get hurt like that. So what your brain is actually going to do, it has specialized these nerve cells so much into the system that as soon as you touch something, even before realizing that it's hot, your brain tells you to move your hand back. Communication has to be so rapid that your skin doesn't have time to get burned, which is pretty much why every time that you touch something hot is not necessarily that your skin is going to get burned. Now, if you look at the photo or the GIF, it shows you how these electrical impulses are transferred. These are nerve cells. Nerve cells take the impulses from here and they're going to move this into the system to the nerve endings. These nerve endings will be joined to another nerve cell, which is going to take them to the brain. So this is like holding hands and forming a chain. So for example, you're standing in a line and you're holding hands with your friends, which are beside you, and you're forming a long chain. Every person in that line is actually a neuron. Or I give you another example, sometimes what happens is your teacher gives you a paper and she tells you, take one paper and pass the others to your kid sitting behind you. So you take one paper, you pass it behind. So what happens is you're moving the information ahead, which is to the kids that are sitting behind you. So that is what happens. Now take the information, pass it to the other. This one is going to pass to the other, then other, then other. At last, it is going to reach the brain. Then brain will do the same thing. Brain will tell you what to do with the information. Then brain will tell you to pass the impulse to the part of the body that was actually affected. Then the second thing is, like I said, every cell is actually specialized. So what are the specializations that my nerve cell has to have? First thing, that it has to have a dendrite that is going to receive the information. For example, this is your muscle. You're trying to hold something hot and your brain knows that this is stupid and you can't really touch something hot. So what your brain is going to tell you, if your muscle is trying to, for example, this is the part of my body that is trying to touch something hot. There are going to be nerve impulses, nerve cells here. These fingers are actually dendrites. They're touching my muscle. My muscle is trying to touch something hot. Dendrites will catch that information and fastly move it to the other. First part was dendrite. Second, axon, the longer part. Dendrites got the information. Dendrites will give it to the axon. Axon will give it to the other part. The last part is your nerve endings. Nerve endings will pass them on to the next. Now, axon has to be long. Why? Because axon is the which can, if it is long enough, it is going to pass your information very, very fast. So the adaptation for your axon has to be that it is long first. For example, in your blue whale, it is approximately 25 meters, which is very, very long. If you hold your hand, if you're fully grown into your height, if you hold your hand like this is 1 meter. Imagine 25 meters. So that is how long your blue whale axon is. Another thing is that if you need to, this is something important for your exam point of view, that your longest nerve in human body is from the base of the spine, where your backbone ends, from that part to the tip of your toe, any toe. Both of your toes, right toe and left toe, are going to have your nerve endings. So one axon, one neuron is going to start from there, the base of your spine, end at the tip of your toe. Second is going to end at the other tip of the toe. Now, the last thing that is an adaptation to your nerve cell is synapses. Synapses is, like I said, dendrites catching the information, axon passing it, nerve endings. Nerve endings giving it to the next dendrite. Now, these are not joined like this. These are having a little space. This space is known as synapses. What happens in synapses is the information jumps. In your body, this information is not in the form of verbal senses, like I am talking to you, I am passing on my information to you. That's not how it works in your body. In your body, it is electrical impulses. Your body converts the messages into electrical senses, electrical messages, and those electrical messages go on. So if they join like this, it is going to damage my cells. So if they have a space, which is your synapses, here they are going to jump. So I hope now you have understood. Okay, so the first question said, which of these cells is a nerve cell? Lakshya said it's B. Do you guys agree? Okay, no. Okay, you agree. So the other question says, which one of these cells is a sperm cell? A. You say A. I agree with A. Okay, so these are the answers that are actually acceptable in your exam. The first one that I asked, which one of these is a nerve cell, the acceptable answer will be axon, because of the reason will be that there's a presence of axon first, or it is a long fiber, or it has a nerve ending, or the cell body and the sheath. So all of these answers are acceptable. Which one comes to your head first? I think that would be good enough. The second reason for why is it a sperm cell, the answer should be that it has a tail and it can swim. The next question is, how is a muscle adapted to its function? Yes, Lakshya, it's a myelin sheath. It's on the axon. Did you guys understand this question? It asks, how are my muscle cells adapted for their function? The function is to contract and relax. So how are they going to do it? I did something like this. So what is this? Muscle contraction A. Very good. I'm glad you guys are understanding it. The next question is, this type of cells sends messages throughout the body in the form of electrical impulses. Which kind of cell sends electrical impulses in your body? Okay, A. Very good. Now this is your last question. The question says, this type of cell is found in males and is responsible for reproduction. Which cell? A. Great. I hope you guys are all clear. Is there any other question that you would want me to answer for you? Okay, so if you guys do not have a question, I would like to transfer this class to your chemistry teacher so that he can start with his lecture. Shall I? Okay, so thank you for joining us. Stay tuned.
Thank you very much, ma'am. And thank you, the entire team of Glecta. You are most welcome on this beautiful and amazing platform of Glecta. Myself, chemistry faculty, and today I'm going to teach you the very special and very interesting topic from the chapter number 1, that is structure of atom, or you can say the atomic structure. Today we are going to cover the very interesting topic, that is atomic number and the mass number. So let us start. After your most welcome. So first of all, I'm going to explain that what are the objectives of our lecture. In this lecture, you will learn how to work out the number of proton, neutron, and electron in an atom or ion. And the second objective, that is how to represent an atomic number in the mass number. And third objective, what is isotopes and isobars. So, and before to start the lecture, I have some expectation from your side that you must know or you have a little idea about the structure of atom and what are electron, proton, and neutron, and where they are located in an atom. You must know before to start this lecture, and I hope so. Now, what are the key points we must know before to start the lecture? That is, what is atom? Actually, it is a very fundamental particles. All the substance are made up of tiny particles that is called the atoms. There are about 100 different type of atoms found naturally on Earth. Then next will be the element. Element is a substance containing only one type of atom. And the third is electron. Electron is the tiny particle and basic particle, you can say, having negative charge, that is 1.6 into 10 to the power negative 19 coulomb. And what is proton? Proton is having the same charge but opposite. Like electron carry negative charge 1.6, that is 10 to the power minus 19 coulomb. And similarly for the proton, it has 1.6 into 10 to the power minus 19 coulomb positive charge. Electrons are present outside the atom and protons are present inside the nucleus. Now let us see, have a look about this structure. You can see there is a center. This center is called the nucleus. It is the nucleus where proton carry positive charge, they are located, and the neutron also present inside of the nucleus. Combinedly, we call them nucleon. Proton plus neutron combinedly known as nucleon. And electron, they revolve around this nucleus in a fixed circular path. This proposal was given by the Niels Bohr. Now let us move about the atomic number. What is atomic number? What do you know about the atomic number? Actually, atomic number is the number of electron present in a neutral atom. What I said, in a neutral atom. But you know that ion carry the positive charge and also the negative charge, cation and anion. So exact definition of the atomic number, that will be the number of proton present inside the nucleus of an atom, because we can't change the number of proton while electron are changeable. If we provide an electron to any atom, that can convert into the negative, and similarly if we remove the electron from any atom, outermost cell of any atom, that can convert into the positive. So the number of electrons are changeable, but number of protons which are present inside the nucleus, that are not changeable easily. Atomic number was proposed by, or it was given by, the Henry Moseley in 1913. So I think it is clear now to you that what is atomic number. Now let us move for the atomic mass, or you can say the mass number. The mass number is different for each different isotope of a chemical element. Now, the question is, what do you mean by isotope? So about the isotope, we will discuss into the next slide. First, let's cover about the mass number. Mass number is the total number of proton and neutron present inside the nucleus, that is known as the mass number. Actually, combinedly, they are known as nucleon. So it is the total number of proton and neutron present in an atom nucleus. They are known as mass number, or you can say it is the total mass of an atom. It is approximately equal to the atomic mass of the atom expressed in atomic mass unit, AMU. AMU is the unit of. Now, hence the difference between the mass number and atomic number, Z, is known as the number of electrons. So we can find easily the number of neutron present in an atom. If we subtract the atomic number from the atomic mass, then we get the number of neutron present in an atom. Now let us move for the next, that is the isotope. First, we will cover the isotopes. Okay, isobar. Isobar is the total number of proton plus total number of neutron. If they are same in two or more than two atoms, then we call them isobar. So isobar means the element or species having different atomic number but same atomic mass, they are known as isobar. For example, if I write here that 6 carbon 14 and 7 nitrogen 14, These are called the isobar, having the same atomic mass. And if we discuss about the isotopes, isotope means having same atomic number. For example, 6 carbon 12, 6 carbon 13, and 6 carbon 14. These are commonly known as isotopes. Another example, 1H1, that is protium, 1H2, that is deuterium, and 1H3, that is tritium. So these three species are the isotope of hydrogen, and these are three isotope of the carbon. Now the next is, what is isoelectronic species? The species having same number of electron, they are known as isoelectronic species. For example, if I say that N2 means there is 7 electron in one nitrogen atom and 7 electron in another nitrogen atom. So the total number of electron in N2, that is 14. And what about CO, carbon? That show the number of electron, that is 6, and 8 electron are present in oxygen. So the total number of electron present in CO, that is 14. So in both the cases, number of electron, that is same. So these two species, N2 and CO, both are commonly known as isoelectronic species. And what is isoneutronic? The species having same number of neutron, that is known as isoneutronic. For example, 7 nitrogen 14. So the number of neutron, easily you can find out number of neutron, that is 14 minus 7, that is 7. Actually, the 14, that is the number of proton and number of neutron. Total number of proton and the neutron is known as atomic mass, and it is 7, that is the atomic number, that is the number of proton. So if we subtract the 7 out of 14, we get 7, that is number of neutron. Similarly, for another, like we have, suppose 6 carbon 13. So the number of neutron is 13 minus 6, that is equal to 7. So the number of neutron in both the cases, that is 7 nitrogen 14 and 6 carbon 13, that is 7, having the same number of neutrons. So combinedly we call them isoneutronic species. You can see their definition. Chemical elements that possess the same number of electrons, that was isoelectronic, and chemical element that possess the same number of neutrons, that is known as isotonic. And it was a very short topic about the general introduction of the structure of atom. What is the atomic number? What is the atomic mass? What are the isotopes? What are the isobars, isoelectronic, and isotones? So if you have any queries, any doubt related to this topic, you can ask through the comment box. Please, I'm waiting you. If you have any doubt regarding this topic, you can ask through the comment box. I'm waiting. Otherwise, we will start the evaluation. Okay, you can send your queries through a message. Now I'm going to start the exercise. The question number 1, that is on your screen. Lead has an atomic number of 82 and a mass number of 207. 82. 82 is the atomic number of lead and mass number is 207. How many proton, neutron, electron does it contain? Please. The number of proton, I'm solving for you. The number of proton, that is 82. Number of electron, that is also 82. And the total mass, that is plus P plus N, that is 207. Easily you can find out the number of neutron. Number of neutron, that is 207 minus 82. That will be your number of neutron. Yes, very good. Devian, you give the answer 82, 125, and 82. Proton and electron, both are same. The number of neutron is different. Very good. Now let us move for the next question. See, there are two isotopes of chlorine having 17 chlorine 35 and 17 chlorine 37. You can see that atomic number is same, but atomic mass is different, so we call them isotope. In terms of subatomic particle, describe the similarities and difference between these two isotopes of chlorine. Similarities that both have the same number of proton, same number of proton. It is similarities, and difference is that both have the different number of neutrons, because the number of neutron in first case, that is the number of neutron that is 35 minus 17, that is 18. And in second case, that is 37 minus 17, that is 20. In first one, there is 18 neutron, and in second one, there is 20 neutrons are present. Now, let us move for the next problem. What is a relationship between the carbon monoxide and nitrogen gas? I'm waiting for your response, please. What is the relation between carbon monoxide and N2? Carbon monoxide and N2. Carbon monoxide, let's check the number of electron present in CO. That is atomic number of the carbon, that is 6, and for the oxygen, that is 8. So total number of electron present in CO, that is 14. And number of electron in nitrogen, that is 7 plus 7, that is also 14. So these two species, that is carbon monoxide and N2, that is the number of electrons. So number of electrons are same in both the cases. So these species are known as isoelectronic. Yeah, okay. On your request, I'm moving back. There are two isotopes of chlorine, that is 17 chlorine 35 and 17 chlorine 37, as per your demand. In terms of subatomic particle, describe the similarities and difference between two isotopes of chlorine. So what is same in 17 chlorine 35 and 17 chlorine 37? Both have same number of proton because atomic number is same. Z is same. Atomic number is noted by Z. And what is different? The different thing is both have the same number of, both have different number of neutron, and you can say the number of nucleon, that is N plus P. Here it is 35. And in this case, the number of proton plus number of neutron, that is 37. I think clear. Can I move forward now? Rida Nadim, can I move? Okay, thank you very much. We have already covered this. These are isotopes. Okay. There was option for you, and we have solved it without the option. That what is the relation between CO and N2? Isotopes, isotonic, isoelectronic, and isobar. You know, isotopes means having same atomic number, same number of proton. Isotonic having same number of neutron. Isoelectronic having same number of electron. And isobar means having same number of nucleon, that is P plus N. So your option was C. Your option was C. Now, one more question. Carbon has dash isotopes, and its dash isotopes is used in carbon dating. Before to start the numericals, I want to tell you that what is the carbon dating. Actually, carbon is present everywhere in anything. And carbon 14, that is the one isotope, most important isotope of the carbon that is used for carbon dating. Carbon dating is to find out the age of fossils and age of rocks. Because the half-life period of carbon is 5763 years, 5763 years. That is a half-life period of the carbon. That's why it is used in carbon dating. So I'm giving you option for A and B. Choose the correct digit or atomic isotopes. For space A, I'm giving you four options. Either it is 3, either it is 4, 5, or 6. And for the B option, I'm giving you 2. That is 6 carbon 13 and 6 carbon 14. There are 3 isotopes of carbon known in nature. That is carbon 12, commonly known, carbon 13, and carbon 14. So your answer will be 3. And 6 carbon 14 is used in carbon dating. Now let us move for the next question. Little hard. You have to correctly match the list M with the list N from the given option. I'm giving you 2 lists, list M and list N. A, option 9, fluorine 19. B, CO2. C, oxygen 2 minus. And the D, O2. You have to match correctly. 9, fluorine 19. Yes, I'm waiting your response, please. 9, fluorine 19. How many neutrons are present? 19 minus 9. So number of neutron is 10. So A option is already matched. A option matched with 1. And what about B? that is CO2. CO2 atomic mass, that is 44, because carbon, that is 12. I'm explaining here about the atomic mass. And for oxygen, 1 for the 16 and having 2 atoms, that's why it becomes 32. So the total mass is 44. Actually, how we can learn the atomic mass for the atom up to atomic number 20, it is so easy to learn. If your atomic number is even, atomic mass, definitely it will be double. If your atomic number is odd, then twice plus 1 you can make it. So that is already correctly matched. No, not matched. B option is matched with the option 4. Option 4. And what about C? Oxygen. Oxygen 2 minus. We know that oxygen having atomic number 8. So the number of proton is 8, but having 2 extra charge. Negative charge means 2 extra electron. So the number of electron is 10. It will match with the third option. And what about D? O2. O2. One oxygen atom having 16 atomic mass. A 2, that will be 30. So D option match with 2. So yes. And let's discuss about some bullet points regarding this structure of atom, and especially this lecture. That atom is about of a billionth of a meter across. It is very small that you can't see through the naked eye. Thank you very much for joining me, and hoping to see you again. I'm certain that your love of learning will take you far in life. So next step is, I'm waiting for your response. If you want to ask something, if you have any query, you can write through the comment box. Otherwise, I'm moving forward, and you stay tuned. We are starting your physics lecture. Thank you very much.
Thank you so much, sir. It's really a pleasure for me to be in front of such a nice audience. So, am I audible to all of you? So, hello everyone, and welcome to you all in World of Physics with Glecta.com. So, guys, we are going to start up with a new topic, that is electrical current and energy transfer. How much we know about electrical current? All right, let's need to know how much we know. Actually, what do we know? In that particular concept, we are going to process about the advanced things that we have up till now don't know at all. But let us go through the topics we already know. So I hope you all are aware of what is a charge. Do we all know charge? What is the charge? Yes. It will be better if the communication will be two-way. Do we know about charge? A matter, a part of matter, a small material around which, space around which will going to attract any other same type of material, like any kind of charge. Either it is positive, either it is a negative. Whenever a charge is going to experience a kind of force by some other body, then definitely we can say that that body is also having a charge. All right, then how charge flow? We know that how charge flow, it always going from higher potential to lower potential. Whenever a charge got the opposite charge force from any mode, either from cell, either from a battery or any kind of mode, then definitely my charge will going to be attracted by that. Otherwise, if there would be the similar charge, it will going to repel it. And this is how a charge flow. So whenever we try to provide any kind of electromotive force, or we can say that a battery, cell or voltage that provides a force to the charge, then we can say that yes, current is flowing. That means charge is flowing. So I hope this much is known to everybody. Yeah. All right. So now we will going to summarize that what do we actually need to know in this lecture. In this, our learning objectives is basically how to calculate the flow of electric charge when you know the current in time. That means if you know how much current has been flown through a body or a appliance, then in certain amount of time, then how much charge has been flown over there. We will going to calculate that. After that, we will going through the topic, that is what energy transfers happens when electrical charge flows through a resistor. After that, the energy transferred by a body by a flow of electric charge is related to potential difference or not. That means whatever energy has been transferred by the flow of electric charge, does that energy is related to potential difference? Today, I'm going to tell you a magical thing that going to change your mind that kinematics and electrical are actually related to each other. Today, we are going to have a discussion about it also, about the energy supplied by the battery. Yes, how we got the energy from the battery. This is the same relationship I need to talk to you about all that. All right. So before starting up any kind of topic, let us understand what is actually going on when we glow a bulb. I want a bulb. I need this bulb to glow. What are the things I need? First thing, I need a cell. If I need to prepare any kind of model or project in the class, then I need to glow a bulb or I need to turn on a fan, then definitely I need some kind of energy by which it can glow, it can move. All right. So for that, we will going to use a cell or we will going to use a battery. All right. So in this, we need to have an object that will be provided an energy. Second, we need a source that can provide the energy. And third, a closed circuit, a mode of closing that circuit, that connect it, and there won't be any space in which that connection can break. All right. Likewise, we say that this COVID can be failed if we break the chain, right? So if we break the chain, then our current stop flowing. Similar case as in COVID cases. All right. So this is very simple thing. This is the simplest circuit you can ever experience. In this particular circuit, I have a wire, I have connecting wire, a bulb, and a cell. And by that, if you notice from this point, if we know this is the positive axis, that is the negative terminal of the battery, this positive terminal will going to attract all the electrons. And these electrons, by the attraction of positive terminal, will going to penetrate across that cell, and then they will going to be thrown out because electrons are negatively charged. Obviously, there is also a negative charge. So they will experience a push from this point. All right. There will be a push from that point that will going to accelerate my electrons to move through the bulb. All right. And from this point, if you notice, that is my, oh, I'm so sorry. That is my positive terminal. This positive terminal will going to apply a attractive force. There will be an attractive force at positive terminal. All right. And this is how they will going to attract the electrons, and in below part, they will going to push the electrons. And by that, there will be a continuous flow of charge that will going to create a current. I hope it is clear, guys. Yeah. All right, so I'm proceeding further. So if we need to know if a current has been flown, our circuit is connected. Now my question is how energy and potential difference are related to each other. So let's find it out. See guys, if I have a battery over here, we have already discussed about what is going on in a battery. It's positive terminal, it's negative terminal. There might be a switch, and this arrow is showing up the flow of current. You can see that electrons have a flow in this direction. That will be the direction of electrons. And we knew that whatever would be the direction of electron flow, the direction of current flow will be opposite to it. Is that right? You can call it positive charge or current. Both have the direction opposite to it. So in this case, we already know that if we applied a battery, we have an on-off switch. That is the switch which is going to connect the circuit if I need it, if I need to turn on my bulb. All right. So in that case, we can say that when charge flows through a resistor, energy is transferred to the resistor. Correct. So whenever a charge is flown, this wire is actually a conducting material, but every conducting material has its own resistance. I hope you all know that. All right. Because that is actually a path for charges to flow. And whenever there is a path to flow, there might be some kind of collisions, and obviously there would be some kind of resistor in it. So either they give you the resistor or not. So this is the one case, but still in this, we already have a resistor, external resistor, which is in the form of bulb. Okay. So in this, whenever a current current is flowing in this direction across this bulb. So whenever a current is flowing across this bulb, there is some, when charge flows through a resistor, there is some energy transfer. So this is the thing I need to tell you, is that whenever a charge flow, it always needs a push and a pull. So what is that push and pull? That is actually a force. So I can say that my battery provides an electromotive force to the charge to flow through the circuit. So whenever a charge is having a force to flow through the flow through the circuit, obviously it is doing a work, and that work will going to convert into the energy. All right. So I can say that very important line for you to remember this all over your life. And while till then you learn the physics, obviously, voltage provides energy. That is a very important thing to learn. Voltage provides energy. And the moment you learn this, you will never going to fail in the concept of electric current flow and potential difference, as well as it is providing an energy. How it is providing an energy? By providing a positive and negative terminal, by providing a push from one end and pull from second end. So this is called as potential difference. In this case, as we came to know that whatever energy is there is a potential difference also. So we can calculate the energy. How we can calculate the energy across it? Let's find it out. So guys, whenever we need to find the energy across it, that energy will be equivalent to how much? Total charge flow. Let me tell you in a better way that will going to help you out. See guys, up till now we have heard about potential difference as voltage, which is equivalent to work done per unit charge. Is that right? Work done per unit charge to make it a flow. All right. So we can say that this work done is almost equivalent to potential difference into the charge. So this work done will going to convert into energy. And this is the best way you can understand the relationship between work done, energy, and potential difference. Similarly, what is a current? Current is a flow of charge per unit time. I is equivalent to flow of charge per unit time. So I can replace Q as IT. And here it is. If I need to find an energy, I'm going to call it V into Q. And to Q, I can say V into I into T from this equation, obviously. Right? So this is how we can find out the energy flowing through any circuit. So let's try a question on it. Okay. Do anybody have a doubt? Firstly, I would like to know if you guys have any kind of doubt. Do you guys are having any kind of doubt? Yes or no? Any doubt, guys? All right. Nobody have any doubt. So may I proceed with the questions? Okay. So here is my first question. That is, calculate the energy transferred when the charge flow is 30 coulomb and the potential difference is 4 volt. So over here, what do we have? We have total number of charges, total amount of charge, that is 30 coulomb. And the potential difference, that is V is given to us, that is 4 volt. So can we calculate the total energy transferred? How much will be the total energy, guys? Anybody?
7.5 joules.
OMG. Everybody knows that. All right. How did you find it out?
30 divided by 4.
Oh, well. So our energy, I have already told you, is equivalent to V into Q. Is that right? Is that right? So we can say that 30 into 4. I think, is that right? Cham? Is that right? Let me remind you once again, what is the potential difference? Potential difference is actually work done per unit charge, or I can say E over Q. then I can say that E is equivalent to Q into V. Is that okay, guys? Please say yes or no. Otherwise, numerical won't be easy for you. Is that right? So thank you for your support. There is one more question for you. Calculate the energy transferred in 60 seconds when a current of 0.5 ampere passes through. Find out in going up. And after that, also, there is a resistor. Check me out. Current is to know. I think you don't like my lecture much. Is that right? Okay. Still, I'm going to help you out. See, guys, we know the value of I and we know the value of T. So if we need to find the amount of charge flowing across it, it will be equivalent to Q equals to IT. So here is my value, that is 0.5 ampere into 60. Okay, so that will be equivalent to 6 into 5, that is 300. And there is a point, so it will be here somewhere. Okay, so my value would be 30.0 coulomb. So that will be my total charge. We know that this is equivalent to Q into V. So that will be 30. Now I need to find potential difference also. So V is equivalent to how much? V is equivalent to I into R. If I'm not wrong, by Ohm's law. We know that. Okay. So in this, we can put the values of current, that is 0.5 ampere, into the resistance flowing across it, that is 12. And the value that has been came up is 12 into 5, that is 60, 6.0 volt. Let's put that value also, that is 6. E will be equivalent to 3680 and 180. So here is the value of energy. So are you all comfortable? If you got the values, different values, then you can find the value of your interest in the numerical. Yes or no? Okay, for a current of 3 ampere that passes through a resistor for 20 seconds. Okay, we again have the value of current, that is 3 ampere. Also, we have the value of time period across which the current is flowing up, that is 20 seconds, and the potential difference across it, that is V, that is equivalent to 5 volt. Again, we need to find the same thing. What do we need to find? Energy. So here it is, energy will be equivalent to Q into V, and we know that Q is equivalent to I into T, so the value will be 20 into 3 into 5, and the value that come out to be 236, 6530, so that must be 300. Is that right? Is that okay with you? That is 300 joule. In this, there is no end to understand how much the concept can exceed to and how small you can explain it in such a, I can just explain it 10 minutes also. It is nothing in this which I cannot explain you in 10 minutes. But yes, whenever you need to go through any kind of numericals that has been came up into your practice session, you need a help. You need a continuous practice for this questionnaire. So here I have one more thing for you, which is very interesting and very important for you all. So guys, this is called Thompson Experiment for the discovery of electrons. In this, Thompson has measured that when he was actually performing his experiment with, you can say, flow of charge, he actually don't know what is positive charge that time. He don't know what is a negative charge. He just experimenting an experiment, and in which when there is a anode and cathode and there is a flow of some particles that can be seen through that particular glass slab, they have noticed that the flow of those charges has been diverted towards the positive axis. If you notice in this is the flow of charge. See, this is the flow of charge and it is actually diverting towards the positive terminal. Can you see that? So when Thompson sir was experimenting this type of experiment, he just explained how a charge is exist. He explained that in this whole universe there is a charge which is negative form, which is of negative characteristics, and its value of this charge is around 0.00000016 coulombs. Then this value of electron charge, that is 1.6 into 10 to the power minus 19 coulomb, came to the world, and everybody came to know, yes, there is an electron, and that is playing a very important role in the concept of chemistry as well as physics. So am I clear, everybody? Are you all aware of all the concepts I have just explained? Yes? If you have any kind of doubt in relative concepts, you can ask me anything you want. Rida, Lakshay, do you have any doubt? Divyan? All right, this is not the end yet. There are much more things that we need to discuss with you all. So don't go away. Please give us a moment. And so I would like you to come, please come forward and do the further proceedings. Thank you. Thank you, guys.
Thank you, ma'am. Really appreciate. Hello all. If you have any questions, the floor is open for you. You can ask any question, whatever you like, regarding the lecture or regarding anything else. In the end, just as a follow-up, we are gonna send the recording as well as all the PPTs which the teachers have used. Basically, we are gonna just put it on our Telegram so that you guys can have access, and we are gonna also put it on our website as well as on Facebook, just for wider benefit for everyone else. And I really appreciate for giving your time to join these lectures, guys. Really appreciative. Have a great day ahead. You can reach us on our email as well as on our WhatsApp or whatever medium you want. Feel free to connect to us in case of any query. Thank you all. Let's close this meeting and enjoy the remaining day. Thank you.